So now we're at the big culmination of all this Lewis dot structure stuff. We're going to predict molecular shapes. So to me, it's pretty amazing just using pencil and paper that you can predict the shape of something so extremely small, right? Like the billionth of the size of the end of a needle. So, maybe not a billionth, a millionth probably. But how we're going to do it, Paul, is this theory called Vesepper. And it's too many words for me to say all the time, so I'm going to be saying Vesepper all the time, Vesepper theory. But what does Vesepper stand for? Valence shell, electron pair, repulsion. Very good, repulsion theory. So all it means is that when you did have a lone pair in your, I don't know, when you did have a lone pair on your central atom, all they're saying is that, man, it takes up a lot of space and it pushes everything else out of the way. That's valence shell electron pair repulsion theory. Then if you need two lone pairs, well, then it's going to go way down to the bottom and push everything out of the way, right? That's the idea behind the Vesepper. So here's some shapes, and what I wanted to do is play around with this a little bit. Here's our central atom. Now for this to work, you can only surround this central atom with identical atoms. Some can't be chlorine, others bromine, others oxygen. No, it all has to be the identical atoms. Otherwise this whole naming thing goes out the window and you have to use something else. So we're just getting introduced to it, so that's okay. So nothing really there so far. So you have to have two surrounding atoms, and there it is. So they call this shape linear. And there's no lone pairs. And all I'm going to do is just keep adding the exact same atom. And then hopefully we'll be able to recognize the name of it and name it. Okay, so that's definitely linear. Okay, so there's no lone pairs on that center atom. Throw in another one. Does it look flat? Lorena, does it look flat? Does this look flat to you? Yeah, right, it's flat. It's definitely a flat object. Okay, but we're not supposed to use the word flat in the name. We're supposed to use the word planar. And then, Steph, we're not supposed to say flat triangle, which is really what it is. You're supposed to say trigonal planar. So we just got to get used to all these words. So you have a center atom with three surrounding atoms, no lone pairs. This is what we have to draw these things. So Connor's pretty much screwed because he can't draw. Neither can I. That's why we're going to practice. Okay, so there's 3, 4. All right. Okay. Ashley, what do they call this? Tetrahedral, right? You could also call it, now you see the flat triangle, you see the triangle on the bottom? You don't look at the center atom, you look at the top one. You could also call this trigonal pyramidal. But tetrahedral is the more common word. But trigonal pyramidal also works because it's a triangle base, and then you have a peak. And realize it doesn't matter how you orient it, it's the exact same shape. So it's perfectly symmetric no matter how you rotate it. It's always tetrahedral or trigonal pyramidal. Add another one. So that's 1, 2, 3. That's 4 surrounding atoms. 5. Okay. What do they call this one? Manuel. What do they call this one? Trigonal bipyramidal. Do you see why they call it that? Why do they call it that, Megan? Why do they call it trigonal bipyramidal? I'm trying to rotate the triangle. All right, trying to spin the triangle around. What happened? There it is. See my triangle? 1, 2, 3 guys. Trying to spin them around. So there's a top and a bottom. So bipyramid. trigonal bipyramidal. You have a top and a bottom. So the naming is supposed to help you. Here's 6 objects. In nature, you surround the center atom with 6 identical objects. It's this shape. And they call this, Emily, what? Octahedral. Now there's another name for this. Do you recognize what it could be? Octahedral's right. You could also name it, you see the center here? What shape is this? And it's got a top and a bottom. Call it what?
Square pyramid.
Close. Square bipyramidal. Because square pyramidal would just be get rid of one of these guys. And that's a game we're going to be playing later. But this would be square bipyramidal or octahedral. Okay. And all those named answers are pretty much there, but okay. Paul told us what VSEPR stood for, valence shell electron pair repulsion. So we're going to start with the Lewis structure, get the electron pair arrangement, and then draw the molecular shape. Now to do this, and to report our answers, it's pretty hard to draw those images that I was giving you. The book and us, on quizzes and exams coming up, we're going to use wedge drawings. So what's a wedge drawing? Well, you've heard of, what are the 3 directions? What are the 3 different directions? Lauren.
Up, down, up, down.
Yeah, you could say up, down, left, right. But they called it X, Y, Z. You remember hearing this? X, Y, and then Z is like coming out this way. Okay? Now, but that's not a wedge drawing. What they want to do is they want to draw, in a wedge drawing, X and Y, the plane of the paper. So when you have a solid line, you're in the plane of the paper. Or if you're drawing on the chalkboard, it's the plane of the chalkboard. Okay, that's X and Y. And then notice how that Z-axis goes, that's your wedge. It's coming straight out at you. That's your wedge. That's your Z-axis. A lot of times they don't draw that solid line, though. They just draw the wedge. So that's coming straight out at you. That Z-axis pointing straight out of the paper. And then it's going straight down into the paper, the rest of the Z-axis. And you're supposed to draw a dashed line for that. Those are wedge drawings. Okay? So trying to draw those 3-dimensional shapes using wedge drawings is what this whole table is about. And then naming them. Okay? So let's see if we can get this filled out and try to get it to make sense. And if you can't see what I'm drawing or what I'm trying to draw, just ask. Okay. So let's start with this total. And this column labeled total is just the total number. You draw your Lewis dot structure, and you find the total number of atoms that are surrounding it and the total number of lone pairs. So it's pretty much the total number of things that are surrounding it. So surrounding atoms and lone pairs. So your total is going to start with 2, and then 3, 4, 5, 6. So from 2 to 6 different things surrounding your center atom. Okay, and that could be atoms or lone pairs, just their sum total. Okay, so if you have no lone pairs, well, it's just linear. Okay, so it's drawn in the plane of the paper, and that's how we're going to draw a linear molecule. I guess you could put so you could either have your answer like that to draw your shape, or start drawing around your center atoms, B's. Sorry, that'd be your surrounding atoms. Your little A would be in the middle, right? But that's the idea. I think it gets more ugly by putting in these letters. But okay, if you have 3 things surrounding it, no lone pairs. We said that was trigonal. Oh, we should write the name. We said that was trigonal planar. Oh, we said this guy was linear. Okay. Let's fill it. We already know the names. 4 things surrounding it was tetrahedral. We should fill this in since, well, it's still in our short-term memory there. Tetrahedral. And then 5 things was trigonal bipyramidal. Remember, there's a triangle in the middle, and it had a top and a bottom. And then if you had 6 things surrounding the center atom, octahedral. Well, we had another name for it. Yeah, or square bipyramidal. I kind of like that name better. It's more visual. Okay. So how do you draw these shapes wedge-wise? Linear, just draw a straight line. Trigonal planar, draw a flat triangle. And they want to keep it all in the x, y, all in the plane of the paper, right? So it would look like this. We're trying to draw this shape, right? These 3 objects, and it's all lies in the plane of a paper. So that's what we're trying to draw. And then your center atom's in the center, and then you have the surrounding atoms all in the ends. Tetrahedral, what you do is you draw your, because remember this could also be called trigonal pyramidal. You have so I'm drawing the peak of my pyramid, and then I draw one of each type of the wedge, right? What's one of each type? I've got a dash, straight, and a wedge. And then it starts looking pretty good. And the order doesn't matter. Okay, that's how we want to draw a tetrahedral. So you've got your triangle on the bottom, right? Your trigonal shape on the bottom, and then you have a peak, so make it a pyramid. Trigonal bipyramidal. See, if you can see these things and visualize, and this is going to be a lot easier to do. What I'm trying to get you to visualize now is I have to add one more. What I'm going to do is add them on the very bottom. And that's going to push these 3 guys up. Do you see that? I'm going to draw another one on the bottom here of the tetrahedral. So I'll have my trigonal bipyramidal. I'll have my top and my bottom, right? Then those 3 just kind of flick out, right? Something like that, right? They're trying to, so I have my triangle in the center. Okay. And then octahedral, you're supposed to, again, remember it's square bipyramidal. So you have a top and a bottom again, except you want a square. So we're trying to draw this shape now. And what they want it drawn like this. They want 2 pointing straight out at you, and then 2 going straight back. So if there's 2 going straight out of the paper, or out of the paper, not straight out, but they're going out of the paper, those are going to be wedges, and the 2 going back will be dashes. So draw 2 wedges coming out at you, and then 2 dash lines, 2 going back. So there's your octahedral.
Do we have to draw that triangle?
So you want to draw them even better than I've drawn them.
Well, no, I'm talking
Right.
about the little shape, I guess.
Yeah, you want that. I'm trying to draw.
That shape.
Yeah, you want to try to draw a wedge. So that you want it to make it look. They're trying to make it look 3-dimensional. You're talking about this guy. They're trying to make it look 3-dimensional, so it's pointing out at you.
Okay.
So, however artsy you can make that look like it's coming right out at you. That's why they kind of draw it that way. It's weird. That's their wedge. So we can do it though, Connor. All right? Okay, now what we're supposed to do is take this shape. So remember, they're supposed to be surrounded. You could write B's on all these guys if you wanted, right? All your surrounding atoms if you want. I don't want to make it uglier, but it might help, right? So you have all these surrounding atoms. Here you have 4 for tetrahedral. You have 5 over here. I don't know if you want to draw these in or not. It's up to you. It really gets really kind of ugly, messy. It was messy before. But there's all my center atoms. And my A is going to be in the center all the time. No, I'm not even going to put him in. But the point is you're supposed to put one lone pair. So you erase a B and make it a lone pair. So I'm just going to make that top one. Oh, let's just do black now. So I'm going to erase him, make him a lone pair. So no longer is this trigonal planar. That molecular shape would be, what would that be? Trigonal planar. Now it is, starts to be bent. Now it's bent. So you call that bent. I do, because it helps me visualize to push everything else down, right? You don't have to circle a lone pair, but I think it looks better if you do, because that's the idea of the separ. It pushes everything out of the way. So if we have one lone pair for tetrahedral, again, we just erase the top guy. So all that's left, right, put a lone pair in. All that's left is my dash, my wedge, my solid. Right? So you have a triangle on the bottom with a little peak, right? And that little peak is going to be my center atom. You would call this what? It's got a triangle on the bottom. Trigonal or trigonal pyramidal or something, right? Pop this off. Now I've got a triangle base with a little tip. It's not flat, so it's not trigonal planar. It's trigonal pyramidal. So that would be trigonal pyramidal. Trigonal pyramidal. Okay. So they're all kind of, when you start working on this and trying to remember it all, they all kind of make sense. It's just this trigonal bipyramidal one is the one where you got to remember to do things in the right way. Because notice how we're going to add 1 electron pair, then we're going to add 2 electron pairs, and we're going to add 3. So what you're going to do is add them around the T. Sorry, add them around this, add them around that center triangle. Where is it? This thing. You're going to pop these guys off. So what you're going to do is first remove that one. All right, so you draw the same shape again. So you've got that T, and you've got a wedge. Wedge. And then you've got your lone pair over here. And so where do you go? So it doesn't really matter which one you pop off. I'm just suggesting, and again, all these, it doesn't matter which one you pop off. It's just easier to recognize the shape if you pop off the ones I'm popping off. So you pop off one of these. All right, we're going to get 3 lone pairs. So here's our first one. And you're supposed to name this. Well, here's the idea of naming it. This is a little guy there, a seesaw. So that's seesaw. Okay, let's just finish this guy. So now we pull off the next one. All right? So again, go around that center triangle and remove them. So you still have your T. We've got our lone pair in the back. And we're going to, now where that wedge is, we're going to add another lone pair. So now we are at, where'd he go? So we had seesaw. Now I'm going to pop off another one. Doesn't matter which one. Now the shape is T. So you call it T shape. Okay, we're supposed to remove one more. So again, you go around that center triangle. So we remove this one. We remove that one. Now we're removing this one. Put the other two in. Our shape is, everybody, linear. Okay. Oh, we kind of didn't finish tetrahedral. So tetrahedral with one lone pair is trigonal pyramidal. So here was my tetrahedral, right? I popped off one. It was trigonal pyramidal. Pop off another one. Now the shape would be bent. Bless you. So and it doesn't really matter which one you pop off. I'm just going to pop off. You're going to end up with a bent shape no matter what. End up with a bent shape no matter what. And then, okay, so now we're down to octahedral. Okay. And what we're going to do is, there's just two lone pairs we're going to worry about. So the first one, again, follow the general order. You just pop off the top guy. Pop off that top atom. So you'd be left with the two dashes going back, and removing this one. And then you're left with those two wedges and the guy going down. So here's my octahedral shape. I've got a square in the center, top and bottom, square bipyramidal, square bipyramidal, right? So pop it off. Now I just have square pyramidal, right? It was square bipyramidal. Now it's square pyramidal. Square pyramidal. And then, again, Vesepper says separate them out as much as you can, so you don't have much choice. You're supposed to pop off the bottom one, because then those lone pairs are separated as far as they can be. Oh man, I'm having trouble drawing this. Let's draw it in first. I'm going to have the two going back, my two wedges, and then my two lone pairs, top and bottom. So you're just left with, is it flat? It's flat, so you better have planar in your name. So square planar. Square planar. Okay. So here's all your molecular shapes. Whether you have 0 lone pairs, 1, 2, or 3 lone pairs for these different molecules. So let's try one here. We'll do one together before we go to the boards and start trying to work this out together. Water. So again, the idea here is start with a Lewis dot structure, draw the best one you can, and then the rest is pretty much the table. Know that table. If you don't know the table, you're up a crick. So, water. Water has how many valence electrons? 6. It should be 8, right? 6 plus 2 times 1 of 8 valence electrons. And what's in the center? Oxygen. Right? So I have to draw on my H's. 2, 4. I have how many lone pairs? 2. Okay, now this is what we would have done before. Right? Okay. But I'm supposed to determine the molecular shape. We should say draw it too. And draw it. So, where am I at in this table? My total is what? So the total is the number of surrounding atoms plus the number of lone pairs. My total is going to be, how many surrounding atoms? 2. How many lone pairs? 2. Yeah, because they're lone pairs, not the lone electrons. Lone pairs. So I have 2 lone pairs, 2 surrounding atoms. My total is 4. So I find my table, right? So I'm going to be in here. And then I think I said I had 2 lone pairs, right? So I have to draw this shape, bent. So if I want to draw it like I did in the table, right, I have to draw it bent. I think, what was it? We had a dash and a wedge, if you want to copy it that way. All right. So you could draw it that way and have your 2 lone pairs. It's bent. Okay. Usually how I do this, because this is getting really complicated, pretty much the only one I memorize is this one. Let me show you what I'm thinking. What I'm thinking is I look at my Lewis dot structure. I recognize that the total is 4. So what I do is I draw my tetrahedral shape, because that's the only one I really have memorized. 4. That's tetrahedral. So one up, and then at the bottom had 1 of each type. And then I remembered, okay, now I have to add 2 lone pairs. So I'm going to add 1 here, up, add 1 there, add 1 over here. That ended up shape is bent. So that's how I strongly suggest doing this, is drawing your Lewis dot structure, figuring out what the total is, then just drawing this one single shape and add lone pairs to it. So much easier than trying to figure out that whole darn table. Because you can identify it if you draw it nice. Again, this is where Connor and I are in trouble. You gotta draw it nice. Okay? So draw it nice, and then you'll help yourself. Figure out the total, draw this column, and your life will be so much easier. All right? Let's try it. So we are drawing these guys. So we are working on ammonium. Ammonium. Okay.
5 plus 4. But it's
Okay. Ammonium. So find out the number of valence. Draw your best Lewis structure, and then draw a 3D guy. So I think you're coming up with 8 valence electrons. Because you got to subtract 1. Right? Is that what we have so far? And then figure out what the total is. The total is going to be...
If you have no lone pairs, how does that
Well, so the total is always the number of surrounding atoms on the center atom and the number of lone pairs on the center atom.
Well, there's no
Yeah, you don't have any lone pairs, so that's just 0. But you have 4 surrounding atoms. So your total will be 4. Your total is really 4 plus 0. Yeah, let's get this one done first. Your total is really 4 plus 0, so it's going to be 4. So draw the shape for 4, and then you're done. And you can put in, all right, draw that tetrahedral. And I think the homework and the quizzes and things, I don't think it's just like this. I think they actually want you to draw the surrounding atoms. I don't think the book really likes you to draw in the center atom, but you can if you want. You can jam it in there somehow if you can still make it look nice. It doesn't look nice though with it in there. But don't forget that bracket with a plus, because it is an ion.
So this is Cl, right?
Mm-hmm.
Okay, good.
Try phosphorus pentafluoride. Each one has 8, and you have 5 of them, so 5 times 8 is 40. So you don't have any lone pairs again. That's good. That's okay. Draw the shape for 5. Oh, that's not the shape for. Oh, that's your. What is this? See, this isn't how you draw it. For tetrahedral, they want those other 3 going down. So
Which one are we drawing?
I'm drawing tetrahedral. Is that tetrahedral?
Oh, that's A. This
What is
is A.
this?
This is B. This is C down here.
What shape are you trying to draw? That's tetrahedral. So that's what I'm saying. It should be. They should be going down so that you can see the triangle on the bottom and the top.
So is that better?
You want to see a triangle on the bottom. I don't see a triangle on the bottom. The way you're starting to draw it is this one, right? Because here you're trying to show that there's a triangle in the center.
Okay.
So there's a big difference between drawing this one and this one.
Okay.
Right? See how there's a triangle on the bottom, triangle in the middle. I was just guessing you're going to have trouble with this. Okay. Yeah. Okay. So phosphorus pentafluoride, you've got 40 valence electrons. I think everybody got this. So to draw the shape for 5, that was that one with that T. Oh, we didn't write names. Yeah. So what do you name this?
It's this square pyramidal.
Yeah. Try to see the shape. Like you got a square. So you try to draw a square in the center, right? And then you've got all that's left. You only see this atom, this atom, this atom, this atom.
Okay, so don't like draw it too big.
Yeah. Well, I don't know. Just try to draw it so that you can see it, right? And then you have F's here. So it just takes takes practice.
They have 6 for events.
Oh, what did I draw?
Well,
What?
see, I don't know. Maybe I'm confused.
Well, you drew the wrong shape then. You drew the
I thought
wrong
it was
shape.
the surrounding plus the lone atoms.
1, 2. Okay, what's our total?
34.
No, our total number of surrounding things.
Oh, 4.
Plus 1
Oh, 1. Oh,
is
okay,
5.
yeah,
So you drew the octahedral shape. No, you don't want to draw the octahedral shape.
Is this good? Or do you want this one to be bent and put the lone pair over here? Because it's a tetrahedral with 2 lone pairs.
You're way down XEF2. What's your total?
4.
For like all
It's
the
tetrahedral.
Okay,
So
but it has
it's
2 lone pairs.
Yeah.
So what I do is I draw the total first. You said the total's 4? The total number of things surrounding it is 4, correct?
Yeah.
Okay, so I would draw a tetrahedral first. Okay, and then I'd put on lone pairs. So I'm going to put one here, put one here. The shape ends up being,
So that's not right?
yeah, no, they
You
want,
want to keep it bent?
yeah, they want it to look like this. 'Cause if you put one on top and one on bottom, it's going to push it up and make it linear. Yeah, they want it. So either when you put those 2 lone pairs on tetrahedral, you just got to put them next to each other. It doesn't matter where you put them. They just got to be next to each other. Like you can put them both here. So that knocks out that instead of a bent. Right. So for ClF4 plus, total 5. And so you have to draw the shape for 5. That was that T-shape drawing. Right. And only 1 lone pair. So let's put the lone pair over here. Seem to put F, F. It's my seesaw. So hopefully you got seesaw for C, right?
So what? How'd you get
Because the total is 5.
oh, that one's falling.
So you had to draw that.
Oh, 5.
Yeah. Because 1 lone pair.
That's what I got.
1, 2, 3, 4, and a lone pair. You
Yeah,
didn't.
I know. No, that's my answer up there, and that's what I got.
No, you drew tetrahedral. You forgot to add this guy. The total is the number of surrounding atoms plus the lone pairs.
Oh, 5.
So your total is 5. So you have to draw the 5 object.
Me too. Like,
Alrighty, so have a good weekend.